I welcome you all to this lecture of Basic Biostatistics. I'm Dr. ASHRAF Jehangir. I hope you already know my profile. I'm an assistant professor in the Department of Community Medicine at Dow Medical College, and my specialty is epidemiology and public health practice. This lecture on basic biostatistics will give you an overview of what does a biostatistician do and what is the use of biostatistics. So the lecture objectives for today's lecture is we'll discuss the definition of biostatistics and we'll enlist the uses of biostatistics and the role of biostatistician in the public health and medical practice and the clinical practice. Then we'll see in the measures of central tendency and dispersion, which are the most popular and the basic start of the analysis in any research study or in any investigative procedure. And then we'll see what are the appropriate statistical software which are available for analysis. And we will discuss a bit about what are the important research steps that requires alignment with statistical analysis. What does this mean? When we'll come to this end of the presentation, this lecture objective, I'll discuss it especially. So if you have any question, you can write it in the chat box. I don't know the current guidelines for why verbal questions, but you can put your questions in the chat box and I'll try to answer all of those. And before starting this today's lecture, I would like to emphasize that in the foundation years and in the hematology module, you have gone through various lectures on related to research, which were on topic selection, objective writing, questionnaire making, literature search, study design, sampling technique, as well as measures of central tendency and dispersion. So these lectures somehow already have given you bits and pieces aspects of the biostatistics. However, in today's lecture, we'll try to sum up everything together, and in this context, today's lecture is very important, and it is rich in the information that you need to hold for your exams as well as for your own research endeavors, whatever. So, as you know, whenever we do research, we need to classify that research into various labels, which are clinical, epidemiological, or experimental or trials research, and the basic sciences research. So in any form of research, we need some numbers to quantify, to analyze, and to make relationship. And for all of these, we need a science which can deal with data. The term data is a plural term, and the singular of data is data. So when we are dealing with data, we need to know how to deal with the data in legitimate manner, what to do and what not to do, the do's and don'ts of data handling, and all of these stuff will make up a science that's called biostatistics. So for any research endeavor in which we collect data systematically, we have to analyze and interpret the data. And for perfect analysis and interpretation of data, we need a science which deals with the data handling. Because biostatistics deals with the data which is related to living organism. That's why we call it biostatistics. There are many other synonymous terminologies available, such as medical statistics, which is particularly works for scenarios in which data is being collected in medical and clinical situations. So um, although biostatistics and medical statistics and even biometrics can be used interchangeably, however, biostatistics is a bigger umbrella term which deals with any biological data, and the medical statistics is especially concerned with the clinical and medical related data. The term biometrics, I leave it to you. Does it mean, and how far it synonymized with the above two definitions. So what are the roles of biostatistician? Although you are fourth year medical students, and maybe very less number of you people in future opt to a field in research which is pure research, and among those very few or maybe negligible number of people opt for biostatistics. Sometimes a medical doctor opt for biostatistical degrees. However, most of the time biostatisticians are those people who have been trained in the pure statistics and mathematics, and they have some specialization in dealing with biological and medical data, um, especially in our country. But the things are changing, and as this field is growing, more and more of the medical community, the doctors are interested to take up a degree in biostatistics or medical statistics. So the the role of the purpose of biostatistician is to guide the experiment even prior of conducting the a clinical experiment itself. What does this mean? This means that the role of biostatistician starts even before the conduct and execution of an experiment or a survey, because the biostatistician tells the clinical researcher about where to collect data, who to collect data, how to sample population, and things like analysis of data and questionnaire making. So the role of biostatistician starts even before the start of or execution of a research study. Obviously, the biostatistician has a pivotal role in analyzing the data, but uh, please understand that a biostatistician cannot analyze data on his or her own. The biostatistician needs the research objective and continuous guideline on regarding the data analysis uh, by the uh, by the clinical researcher. A clinical researcher must sit with the biostatistician and guide the biostatistician regarding the type of analysis he or she wants. In case if some biostatistician is analyzing a clinical data on his or her own, there are many chances that this biostatistician make mistakes which cannot be detected later or cannot be corrected later. So it is a good practice that if you want to consult a biostatistician, you should sit with him for your data analysis, or at least provide him or her a detailed guideline for your data analysis. And finally, the role of biostatistician is in the presentation of the data, because analysis is not the end of the research. Finally, you have to present that data to the rest of the world, the governments, the NGOs, or your funders, or maybe industries, so or maybe your peers and the population and patients. So you need to convey your message, which is being derived from your research, to the masses. And at that moment, uh, a simple and easily understandable message is very important. And for that easily understandable simple message, the role of biostatistician is important. So uh, uh, now you can perceive by this slide the role of biostatistician. You can perceive the uses of biostatistics. So um, we have the knowledge of statistics is essential for people going into research, management, or graduate studies. Why? Because there are so many things. Say, how do some, if we take an example of IV cannulation. So for an IV cannulation procedure, we need an IV cannula. And that cannula has different gauges, different sizes: 18 gauge, 20, 21, 23, 24. So the higher the number, the smaller the size of the cannula. How could we know which size of the cannula is appropriate for which patients? Here comes the use of statistics. The statistics can tell you what size of cannula should be made, or what size of trocar should be made for what age group or the gender of the patient. So according to the gender and age of the patient, the size of cannula are being built. Similarly, the cuff size of blood pressure sphygmomanometer apparatus. We know that uh, there is a normal cuff size apparatus available in the market, but in case if you are dealing with uh, overweight and obese patient in your clinic, that cuff size is not appropriate, and for that you need some measurement, and that measurement comes from by the use of biostatistics. So biostatistics is useful for conducting investigation and making effective decisions. So for any research endeavor, as we discussed earlier, biostatistics is important. However, one thing should be noted here. I forgot the name of that person who said this quote that there are lies, damn lies, and biostat and statistics. So if statistics is in the wrong hand, if the biostatistician is not trained and not fair, that biostatistician make more blunders, more mistakes, and can totally bias the results of any research study. So statistics is like a knife. You can use that knife to harm your research study, or you can use that knife to make beautiful pieces and tailor it according to your need of the of your research study. So the most important thing for statistics is a statistician has the power and has the skills and knowledge to infer using a sample data from a population. So what is a population? Population, by definition, a population is a set of measurements of interest to the researcher. However, in general term, we consider a population is population of people. But in the research sense, a population could be anything which is of your interest. For example, a population could be animal population. A population could be the CBC sample, complete blood count samples, which arrived in your laboratory today. For example, 1000 samples arrive in your laboratory today, and those 1000 samples are your population of interest, because today there was an epidemic kind of thing in which 1000 people were affected, and their blood samples were sent to your lab for analysis. Would you do the analysis on the whole 1000 samples? Maybe not. You may take a sample out of that population, and that sample will help you decreasing the cost, increasing your efficiency, and decreasing the time taken to infer about that epidemic. So on the basis of 1000, or on the basis of that 1000 population of blood samples, you can take an appropriate sample, which could be 200, 300, or maybe 100. It depends. Say if you have taken 100 sample from that 1000 population, now you can analyze those 100 sample and make inference on the basis of that sample, and that your inference would be valid for that whole 1000 population. So a population could be income of household living in Karachi. The other example could be the number of children. So you can see a population could be anything of your interest. If it is a health status, then it is the population which you are dealing with. So what is sample then? It is a part of the whole, a subset of the population. In the statistics, we deal with descriptive statistics and inferential statistics. Most of the time, we just deal with the numbers for the purpose of enumeration, counting, and organize the data, 30% here and 70% here, and we just present the data in charts and graphs. That kind of statistics is called descriptive statistics. However, most of the time we are concerned about to make relationship, to make the jigsaw complete, to make a complete picture with the help of the available information. And most of the time the information is not complete. Here comes the use of inferential statistics. Inferential statistics can give you the power to infer about certain things using the sample data, and that sample data uh, uh, can make relationship between two or more than two parameters, or can help you estimate the prevalence or incidence of any disease or condition in any area. So here we have an example of estimation for inferential statistics, that we can estimate the prevalence of hypertension among adults living in Karachi. Do we know how many, what is the population of Karachi? Say 2 crores, 20 million. Do we know how many, what percent of adult population is hypertensive? We don't know. So can we estimate that? Yes. How? Should we go for all the adult population in Karachi? It would be anything like 40% of the Karachi population would be adult population. The rest are children. So 18 and above population would form 40% of the Karachi population. That means 8 million. 8 million of the Karachi population are adults. Would we go for the whole 8 million to estimate the prevalence of hypertension? No, because it would be inefficient. It would waste our resources, money, time, manpower. So what we will do, we'll take a sample out of those 8 million adult population, a sample which is big enough and representative enough and approached in a correct manner, so that none of the eligible adult person in Karachi is left out. And on the basis of that sample, which could be a few thousands adult sample, can make inference on the whole adult population of Karachi, which is 8 million. This is something very beautiful because we are extrapolating our findings based on a sample taken from a population and referring it back to the whole population, extrapolating it to the population itself. That is something very beautiful because here you can save resources as well as the discomfort to the people. So this was something about estimating something. The second thing is testing hypothesis. So here comes the use of biostatistics as well. For example, we have two types of drug, for example, two types of vaccine against COVID-19. How do we know which vaccine is more effective to prevent COVID-19 infection in adults? Here we need to test the hypothesis that there is a difference in the effectiveness of vaccine A and vaccine B against COVID-19 infection. So we can use the data. For example, one group of patients will receive the vaccine A, the other group will receive vaccine B, and then we will compare after a certain period of time. Did they contract COVID-19 infection down the line, 3 months, 4 months, 5 months, because 1.5 months would take for the development of immunity, at least 1 month. So in this manner, we can test our hypothesis that which vaccine is effective. Say vaccine A has more number of COVID-19 infection patient or sign symptoms of COVID-19 than vaccine B, so vaccine B is more effective. While using or studying biostatistics, a keen researcher must know the sources of data. This is a very, very important topic because if you don't know the sources of data, you cannot use your resources and time efficiently. Most of the data may be available through other sources, for example, surveillance systems, or maybe conducted surveys by the government or NGOs, or maybe some education institutions, or sometimes data is available by the clinical trial units or experimental organizations such as pharmaceutical companies. So this list is unexhaustive. There could be many other 1, 2, 3, 4, 5, 6 and so on number of organizations where you can get already collected data, which is indispensable for the purpose of your research. So a biostatistician, when a biostatistician is doing the drafting of a research study, he or she must ask the researcher that is this a survey or an experiment, because these are two contrasting type of research design where the analysis depends on the type of study design. And I'm not going into the detail of what is a survey and experiment, but you should know that the type of analysis, these two type of research study design is entirely different. So the other purpose, or the role of statistics or biostatistics is helps in sampling method. Helps the researcher in sampling the population. So there are methods which are called random sampling or scientific sampling method, probability sampling method. And under the probability sampling method or random sampling method, the simplest one is simple random sampling. While the other nomenclature of sampling, that's classification, is systematic sampling, stratified, cluster. The top 4 sampling methods are considered scientific and less biased or minimal bias sampling method. The fifth one, the convenience sampling, is haphazard sampling. It has more bias and it is a researcher should try to avoid a haphazard or convenience sampling in the more complex sampling methods are usually advisable for clinicians because they are working in the clinics or hospital environment, and more complex sampling methods are usually more appropriate for large population samples or large geographical areas. So while doing the analysis, I hope most of you people SPSS, Statistical Package for Social Scientists, or it is also named as a Statistical Package for Solution. It is a statistical software, very popular and easy to use, SPSS. And that SPSS, when you try to enter data, you always wonder how to code the data. If your data is regarding height, weight, and any variable which is itself purely quantitative, such as height. Height is always in meters, centimeters, or feet. Weight would be in kilogram, grams, or pounds. So these are quantitative data. So whenever you are dealing with quantitative data, pure quantitative data, do not code it. Do not code the quantitative data. Initially, at least, do not code it. However, there are certain variables where you cannot make quantification, such as sex, gender. Gender is either male, female, or better not to say that. It's something that's been written on the in the performers and on the internet that it's third gender kind of thing. So male, female. If we can group or classify or categorize our data into meaningful two or more than two categories, then that data is categorical or qualitative data. And it is important in the biostatistics because most of the analysis depends on the type of variable and the type of data in it. If your variable is categorical, your analysis choice is different. And if your data is quantitative, your analysis choice would be different. So categorical variables such as sex or gender, marital status, maybe income category, rich, poor, middle income. Quantitative variables, or also called numerical or continuous variables, are age, height, weight, income, and time in minutes or seconds, or maybe days or years. There are other variables which are quantitative, but which cannot be presented in fraction. Those are discrete variables, such as number of children. So number of children could not be 1.5 or 2.5 or 3.2. So when you count a human being, you can say 1, 2, 3, 4, a whole number. So it's a discrete variable. It's still a quantitative one. There are responses or variables where we only get yes or no answer. That's called binary or dichotomous variable. It is important to know because at the time of analysis, these things matters. The scale of the variable. Here I would like to show you. I would share the screen. New share, and here is the SPSS screen. Anis, can you hear me? Mr. Anis? Students, can you see the SPSS screen I have just shared with you? Just type yes, no, yes. Yes, thank you. Thank you, Zahra Koitawala. Okay, so thank you, Khala. So here you can see the SPSS interface, and you can this is real data. Data I just downloaded, which were collected by my student, and you can see it was collected in June 2021 and just finished the data collection now. So we have age, gender, and other variables in our data file. And you can see the type of data here, nominal or ordinal or scale data. A scale data is something, a quantitative data, such as you can see scale data denotes weight or height thing, or maybe BMI scale data. However, marital status is considered as nominal data, while ordinal data has some logical order, such as mild, moderate, severe, very severe, from low to high, or maybe agree, strongly agree, disagree, strongly disagree. This is again ordinal data on a Likert scale. So back to our presentation. Where is my this one? So variables could be different types, such as nominal variable, where just the name is important, such as marital status, married, single, or cohabitant, anything. Okay. Ordinal scale variables such as mild, moderate, severe, for example, for pain. Interval scale such as the temperature variable, and ratio scale such as the height and weight variable. So nominal variables or nominal data, these data do not represent an amount or quantity. Ordinal have an ordered series of relationships. Interval data has an arbitrary zero. So for example, temperature in Fahrenheit, a 0 Fahrenheit temperature doesn't mean the temperature is zero. Zero means nothing exists. So a 0 Fahrenheit temperature doesn't mean temperature does not exist. It exists, but cannot be recorded on Fahrenheit scale. Can be recorded on any other scale, such as absolute or Kelvin scale. And interval ratio scale are the true variable which have meaningful zero, such as weight or height. So most of the time when we write our own synopsis and project or research report, most of the time the scientific committee or the IRB committee asks us, what is your independent variable, what is your dependent variable, which one are confounding variable, and maybe the intermediate variable. So here you should understand that what does these things mean. Independent variable, what are these? Independent variables are those variables which are risk factors and which are putting an effect on your outcome of interest. So that's why they are called independent variable. While the dependent variable is the outcome of interest in your study. Most of the time it is a disease, but sometimes it could be a condition, anything. So for example, if you are doing research on the effect of drug A and B on uh, um, uh, sugar control, on HbA1c levels. So the change in HbA1c levels is the dependent variable, while the drug A and B are the ones that are putting an effect on the HbA1c. So drug A and B are the main risk factors. Other than A and B drug, patient will have certain gender, it would be independent variable, certain age, it would be an independent variable, and many other things such as ethnicity, education, and other comorbidities. So now you should know that what is the difference between dependent and independent variable. And what is confounding variable? Anything other than main risk factor and the main outcome variable. The third variable, which is mixing into the relationship of this independent and dependent variable, it could be a confounding variable or could be an intermediate variable. The decision of whether it is intermediate variable or a confounding variable lies on three-pronged test, which we can discuss in another lecture on hypothesis testing. So there is a difference in the gist is there is a difference in the confounding and intermediate variable, and the difference is important. And how to find out that whether it is a confounding variable or an intermediate variable, you need to apply a three-prong test. And that three-prong test, you can search it on the internet, or you can leave it for another lecture when we can discuss it. So now this is time to present your data. This is one of the aspect of biostatistics, to present data. You can present your data in tables. You can present your data in charts such as histogram or other types of histograms such as frequency histogram or polygon or frequency polygon. There are many other types of charts such as bar charts, stem and leaf display, and box plot. Not all of the charts are. Hello. Do you have any question? Okay, so not all of children 0, 1, 2, 3, 4, 5, 6, 7, 8. Women could have maybe have no children at all, or could have 8 children at max, for example, for in our sample data. So how many women's have 0 children? 2. How many had 1 child? 3. 2 children? 5, and so on. So in total there were 30 children, and out of those 30 women, what percent of women had 2 children? 2 out of 30. So we can find out the relative frequency. This is a display of data in frequency table. This is called frequency table, right? The similar data can be depicted in a graph. This graph, you can see 0 children on the horizontal axis. You can see 0 children, 2 women's, and 1, 3, and 2. This is the same data, but a different way of presenting data. So it is your choice. In your research paper or research report, would you like to present data in graph, chart, or maybe frequency table only, or maybe both? But you should not repeat the presentation of data in more than one places or one display method. So if you are presenting data in the charts, do not present the same data in the tables. This is the way we write our reports. And this is the role of biostatistician and researcher while presenting his or her results. I hope you all are aware of mean, median, and mode, but for the clinical sciences, these have more meaning than just central measures of central tendency, because most of the time we need to find out what is the, for example, if we are managing a group of patients who are diabetic, and a patient comes to you with a raised HbA1c, what would you do? Would you start amending or changing your therapy, anti-diabetic therapy for that patient? No, you can always check back the previous HbA1c for the past maybe 6 months or 1 year. How was the control of sugar in the past 1 month or one year? And that control can help you. That average HbA1c level can help you to decide efficiently for that specific patient or group of patients. Most of the time when we are measuring mean is affected by extreme values. Very low values or very high values in the series can drag the mean on their side. So if you have a data on 100 participants about their body weights, and if you have most of the participants having body weight, adult participants having body weight 50 to 60 kg, and 4 or 5 participants having body weight exceeding 150 kg, for example, that means your data is right skewed, and you should not only present the mean value and standard deviation. You should present the median as well. Even if you have very lower sided value, very extremely low value in your data series, you must present the median along with mean. Whenever you present mean, you must report the standard deviation. And I hope nobody will ask what is standard deviation, because it is a topic of foundation years which we discussed earlier. If you are unsure, go back and read it from there. While you are reporting median, you must report the range or interquartile range of your data. So how do we measure the dispersion or variance or variability in the data? The simplest method is range. A more sophisticated method is variance, and a modified method which is more standardized is called standard deviation. This is the formula for standard deviation. I'm not going into the detail of this formula because most of the time you will not be calculating anything by hand or calculators. You will be using computer softwares, SPSS, for calculating these type of simple calculations. So this standard deviation and the further derivation from the standard deviation such as standard error and 95% confidence interval gives you and follows some empirical rule. Most of the variables follow empirical rule that within one standard deviation above and below 68% of the measurement of your sample fall, and you can make an easy inference based on your sample data regarding your population. Within 2 standard deviation below the mean and above the mean, 95% of the measurements fall. And this is the standard deviation cutoff which we use most of the time in our research studies and clinical sciences. We use this 95% of the confidence level and confidence interval level for calculating or estimating our sample size, for interpreting our results, interpreting the p-values, and reporting our results to the uh, rest of the world. Anything above 95 is your choice, but not mandatory. So 99.7 correspond with the 3 standard deviation around the mean, and it says that uh, for the whole distribution you have captured 99.7% of the observations. So suppose the reaction time of a particular drug has a normal distribution with a mean of 10 minutes. So reaction time or bioavailability of a drug is normally distributed. On an average, it takes 10 minutes to be available biologically in the human system, 10 minutes. And it has a standard deviation of 2 minutes. What does this mean? It means that if we are for A, B, and C. For A, if we are considering one standard deviation, which is just 2 minutes. So one standard deviation 2 minutes below this average and above this average would be the reaction time of that drug. So one standard deviation. 10 minus 2 is 8 and 10 plus 2 is 12. 68% of the subjects taking the drug will have reaction time between 8 and 12 minutes. This is something very beautiful. On the basis of your sampled research, you can now tell the whole world that if someone in the population is taking this drug, we can say that 68% of the subjects will have a reaction time between 8 and 12 minutes. What about the 95% thing? So 95% is more conservative estimate. So here we can say that 95% correspond with 2 standard deviation. So 2 standard deviation means 2 minutes multiplied by 2 below the mean, 2 minutes multiplied by 2 above the mean. That means 10 minus 4, that means 6 and 14 minutes. So 95% of the subjects taking the drug will have a reaction time between 6 and 14 minutes. This is something very, very beautiful, because this empirical rule and your data and sampling the sample which is taken from a representative population gives you the power to extrapolate your finding to the bigger group. You don't have to study the whole populations or whole community, just few hundred or few thousands people. So here you can appreciate that if this standard deviation would be less than 2 minutes, say 1 minute. If it is 1 minute, then everything will change. The less the deviation, the less the variability, the more the power you will have to precisely estimate the reaction time of that drug. If this 2 minute is changed into 1 minute, then this 8 and 12 minute would be 9 and 11 minutes, and this 6 and 14 would be 8 and 12 minutes. So you can say that 95% of the subjects taking the drug will have a reaction time between 8 and 14 minutes if the standard deviation is just 1 minute. So let me check the time. So time is up and the lecture is on dot, on time. Most of the slides I took from my mentor and my professor, Dr. Muhammad Rahbar. who was a professor of biostatistics at Aachen University, and now he's working in the Michigan State University. A wonderful person and a perfect professional. I thank you all for your patient listening. If you have any question, you can write in the chat box, and I'm reading the chat now. Anything? Anis, Mr. Anis?
जी सर
अभी कितना टाइम है हमारे पास लेक्चर कंप्लीट होने में?
7 मिनट
7 minutes है. Okay, students, you have 7 minutes. If you want to ask any question, you can write in the chat box, and I would love to answer those.